Okay, we are looking at some of the fraction number sense, which is in chapter 14, okay, and also in the discussion board possible problems this week that you have to choose from. We are being asked here to order these fractions without calculations, okay? So we're asking students to be able to reason and compare fractions without having to do cross products or convert to a decimal or cross multiply or find common denominators or any of those other calculations that we're asking them to do. Remember, one of our focuses is how much math, how much mental math can we teach as a reasoning skill, okay? Getting students to understand that basic number sense for fractions will help us be able to do that, okay? So there's 4 ways in which we really can kind of think about this, and they're very easy ways if you just learn to reason about quantities and understand what the fraction is representing when it is presented to us. So let's start out with probably the most simple way to compare fractions. It's when we have the same size whole or we have the same denominator. Okay, now how do we know this? The denominator, remember, tells us the worth. When we're looking at a fraction, we really have to think of it as 2 parts of one value. Okay, the top number is our numerator. It does the counting. It tells us how many parts we have, whereas the denominator focuses on the worth or the size of each one of the parts. Here we have 4 out of 5 parts. How does that represent size? Well, because we know each part has to be 1/5. Okay, since we have the same number of parts to make a whole here, we know this has to be the same size whole that we're comparing it to. So we have 4 out of 5 parts or 3 out of 5 parts. Now, we are assuming that these fifths, okay, that every fifth of a whole is equal. So we know that we're working with the same whole. If we have 4 1/5 and 3 1/5, and each 1/5 is the same, of course 4/5 is going to be the larger amount here because we have more of the same size parts, okay? One of the things I often ask students in my elementary math education course to consider is think about coins, okay? If we were just comparing dimes, 4 dimes or 3 dimes, okay, count and worth are the same thing, okay? 4/5 or 4 dimes, of course, would be worth more than 3 dimes because each dime is worth the same thing. It's kind of the same concept that's happening here. However, that's not always true. I mean, think about it. Would you rather have 20 pennies or 2 quarters? In that concept, worth and count are not the same. So we have to keep those two sort of on the forefront of our concentration when we think about fractions. Okay, so of course here 4/5 is the larger fraction because we're simply counting the number of same size pieces. Okay, so let's get down into the same number of parts. That would mean we have the same numerators, but we could have different denominators here. Okay, so we have 5/9, 5 parts out of a whole of 9, or 5/7, 5 parts out of a whole of 7 parts. Okay, now which number is bigger? Okay, we know we have the same number of pieces, so that is sort of useless in helping us determine which one is larger, because if I have 5 here and 5 here, that really doesn't differentiate. So all we can think about next is the size of those pieces. We have 5 of both of them. The count is the same, but what is the worth? Okay, if we're thinking about these parts over here, these parts are all going to be 1/9. Over here, these parts are 1/7. Okay, now one of the things we should be able to pick out at this point, and your students should as well, if you're getting to the point to where they are comparing fractions, then they should have some conceptual understanding that 1/7 is going to be bigger than 1/9. Okay. And the old explanation that we used even back when I was in elementary school, if we cut a pizza into 7 pieces and we cut a pizza into 9, the one that we cut into 7 would have bigger slices, assuming the pizzas were the same size. Okay. So I've got 5 of a bigger part here and 5 of a smaller part here. If we were to lay those out and see how much area they took up, obviously 5 of the larger piece would be more area that would be represented there. Okay, so the third strategy we can use is thinking about comparing the fractions to 1 or 1/2. Okay, so let's start out with this first example. We've got 2/3 or 3/8. If we're trying to figure out which one is larger, and again, we are not going to use common denominators, we're not going to do percentages, we're not going to do any of those calculation procedural methods. We're going to try to reason which one of these should be bigger. Okay, if I think about this here, I have 2 out of 3 parts. It takes 3 parts to make my whole. Here I have 3 out of 8 parts. It takes 8 parts to make my whole. Here I can compare pretty simply to 1/2. If I'm comparing to 1/2, I know that half of 8 would be 4. So this 3/8 has to be less than a half. Okay. Now 2/3, if I were thinking about thirds or just 3, if I split that in half, I'd have to have 1.5 parts. So this is more than a half. If this is worth more than a half and this is worth less, then this clearly has to be the fraction that's worth more. You also could do this if you were comparing to 1. For example, let's say we had 8/9 or 3/2. Okay. If we were thinking about this, of course, I know also as adults, we have understandings about decimal relationships and values here, but remember that students do not do that. Here, always do that. Here we have 8 parts out of 9. We don't have a whole. We have 1/9 less than a whole. Here we have 3 out of 2 parts. So we have enough to make a whole with some left over. So this being larger than 1 and this being less than 1 lets us know which fraction is larger. Okay. Now, we also, instead of just doing greater than or less than 1/2 or 1, we can also do some comparisons by talking about the closeness to 1/2 or 1. Okay. So let's look at this first example. I have 11/24 or 17/30. Okay. Obviously, I could also think about a comparison here using the same strategy that I just looked at, which is that 11 out of 24, that's less than a half. Okay. 17 out of 30, that's greater than a half. So without even thinking about the closeness, we know that this one, of course, is going to be larger. Now, when does this strategy of closeness actually come into play? Let's look at this comparison here. 7/8 or 10/11. Okay. Now, why can't we talk about just greater than or less than a half? Both of these are greater than a half. That doesn't really help us distinguish because there's no difference if we're just comparing in that way. 7/8 would be more than a half, so would 10/11. So how could we compare this? Instead of closeness to a half, this one I'm actually going to use the idea of closeness to 1. Okay, so let's look at 7/8 first. How close is it to 1? Okay, we would need an additional 1/8. So this one is 1/8 away from 1. Okay, now what about 10/11? This one is 1/11 away from 1. Okay, now if we're wanting to order these in size, which one of these is farther away from 1? We know that this 11th should be a smaller piece than the 8th. Since that's true, this is a short distance from 1. This is a bigger distance from 1. If that's the case, this 10/11 should be the larger fraction based on that reasoning. Okay, so this takes a little bit of practice. okay, to ask yourself to think about it. So when you are working through not only the homework problems, but in addition to that, looking at some of the practice problems on the homework feed, this would be a really good video to come back to when you're in that position.